Okay. So that's chemical and physical weathering. Now, with physical weathering, there are a couple examples that we talked about. What should go in the first blank there? It means when two rocks rub, bang, or grind together. What was that term we talked about yesterday? We put a box around it in the reading. Riley? Aiden? Not erosion. That's coming up in just a little bit. It sounds very similar, though. Luke? No, it creates friction. Manny? Abrasion. Very good. Rubbing together of rocks. Rubbing, grinding, or banging together. What should go in the next blank? Blank, blank in rock cracks. What happens with rock cracks that causes them to physically weather or just get smaller? Jacob? Yes, freezing water. When water kind of seeps into the rock and then freezes in the crack, the water expands, pushing on the crack and causing the rock to break apart. And the last one, blank, blank, growing and breaking through the rock. Riley? Plant. Yes, plant roots. Very good. Plant roots growing and breaking through rocks. Okay, so that's weathering. That's breaking the rock down into smaller pieces. What is erosion then? Layla? Very good. It's the transport of Earth's materials from one location to another. Aiden? Oh, you gotta write faster. Without changing what the rock is made of. Okay? So erosion, weathering is when the rock breaks down. Erosion is when it's carried off by something. What is the most powerful agent of erosion? Wyatt? Pardon? That is one example, but it's not the most powerful one. Good question. Now, it does take out the most stuff in its path, but just purely like having a stronger pull. There is something else that has a stronger pull. Kayla? That's what he said. Sadiksha? No, good guess though. Layla? No, that's another cause of erosion, but it's not the most powerful one. Matthew? Water. Water is the most powerful agent of erosion, or the most powerful cause of erosion on Earth. Yes. That's very true. Now, you guys did name the other types of erosion as well. Wind picks up small particles and blows them around. And then ice, in the form of glaciers, can pick up and move the rocks. Yeah, glaciers. Forgot about that. Yes, Riley? The next one? Sure. What is deposition? Erosion makes them move, and then deposition is when they drop. Very good. Okay? So, for deposition, I want you to write that key word again off to the side here. Drop. I want you to underline the D in deposition and the D in drop. That's your clue to remember what deposition means. Deposition is the settling of Earth's materials carried by water, wind, and ice. Okay, so weathering breaks them down. Whatever agent of erosion causes them to move somewhere else, and then wherever they drop, that is the deposition process. Aiden? Because some people write very big. I don't know. I'm nice. Give you lots of room. I have no idea. All right. So the rest of our notes today are going to be on the PowerPoint, which I'll pull up in just a minute. But we're going to be talking about 4 different landforms in particular. Okay. Now, yesterday, when I went through the landform photo album with you, we saw many different types of landforms, right? Everything from mountains to valleys to volcanoes to all kinds of stuff. So today, we're going to talk a little more in depth about 4 of them in particular. But first, we're going to get a definition for what a landform is. So, a landform is a feature of Earth's surface. A feature of Earth's solid surface. So, this could be mountain, valley, river, canyon, I don't know, geyser. Geyser, okay? Any kind of feature on Earth's surface can be considered a landform. So, the first one we're going to talk about in particular is a glacial valley. Okay? A glacial valley. A glacial valley is formed by the movement of a glacier, which we know from our reading yesterday is a big mass of moving ice. Okay? And these are shaped like a regular valley, right? Most valleys are formed by streams. They're stream valleys. They have a V shape. But what do glacial valleys have that's different? How do they look different in a regular valley? Connor?
They're U-shaped.
They are U-shaped. Very good. So, off to the side, somewhere in your notes, I want you to write this. In quotation marks, somewhere near Glacial Valley, either maybe in like the left-hand side, yeah, kind of where yours is, that's good. Okay? I want you to write U-shaped in quotation marks. You do have to know that for the test. Glacial valleys are U-shaped. Okay? You can even see it in this picture right here. That's kind of more of a U shape going on. Okay? A glacial valley is formed by falling ice that eventually melts and leaves behind the area it dug out. We also talked about how a glacial valley is more like an ice cream scoop, kind of digging through the ground as opposed to like a pencil or something. Okay? A pencil is going to form a very distinct pointed line, correct? However, an ice cream scoop is going to give you more like a big dip. Okay? So the glacial valley takes out everything in its path, moving things around kind of like a bulldozer. Okay? Aiden?
Now that I look at the one, now I can see why it looks like ice.
Perfect. I'm glad that helped. Brooklyn? Just watch it roll around. It does. Connor?
Were we supposed to write that down?
Write what down?
The glacial valley.
Yeah, you fill in these blanks for number 1.
Okay. Okay.
So number 1, you should write Glacial Valley.
It says a landform formed by the movement of a glacier
Shaped like a valley.
Not like a U.
I mean, you could put U-shaped valley there, that's fine. But shaped like a valley. The goal here is I'm putting the notes up on the board and you fill in the blanks for whatever you're missing. Okay? You good? Okay. All right. Next one we're going to talk about is a delta. You learned in history what a delta is. In science, we're going to talk about how the delta is formed. A delta is a landform that is usually located where a river runs into a larger body of water, such as an ocean or maybe a lake, pond, things like that. This is caused by sediments. What are sediments? We learned that word yesterday. Riley?
Tiny rocks.
Tiny pieces of rock. Very good. Man, Riley, you must have really enjoyed the reading yesterday. Sediment, tiny pieces of rock, building up as river water moves from higher to lower elevation. I'll explain what that means in just a minute. A delta is formed by water. The water moves the sediment. Okay, so everything that I have underlined up here should be blanks in your notes that you're writing down. Yes? Okay, good. Once you write that, look up here. I'm going to explain the process a little better. Every once in a while, I gotta keep checking my camera and make sure the light's on so I'm recording. Yeah. Yeah, kind of. So what happens is this. Okay, let's take the Mississippi River, for example. Okay, here's the Mississippi River. Eventually, the Mississippi River, empties into the Gulf of Mexico. Okay, so there is a delta down here, the Mississippi River Delta, where the river branches off into several smaller rivers before it dumps into the Gulf. Okay, and this is why. As the river is flowing, let's look at this first. Think about if a river is flowing down a hill, right? Eventually it gets to the bottom of the hill and has to level out, correct? Okay? When the river gets to the bottom of the hill and begins to level out, something has to happen to all those rocks and sediments that the river has been carrying all this time. Well, when it gets to the bottom, what happens? They get dropped. They have nowhere else to go, right? So they flow, comes down, and all the sediments drop off where it levels off at the bottom. Okay? Well, as those sediments get deposited over time, they build up into bigger and bigger piles. Eventually, the pile gets so big that it pokes out of the water, correct? Well, when it pokes out of the water, now the river can't go over the pile. It has to go around the pile, right? So now this one river has had to split off into two branches to go around the pile. Yes? Okay, so that's what happened here. Here comes the river, is coming down. The sediments built up here, and now so much so that it came up out of the water. Then the river had to split and go around it. Okay, keeps going down here. Sediments now are starting to build up here. So the river has to split again and go around the pile. Comes down here. Sediments build up again. Has to split and go around the pile all the way out. And that keeps happening through all these different branches of the river. You see? Okay? That's what forms the delta. If the river is carrying all those sediments, it begins to build up and create piles to where the river has to branch out and go around it. You see what I'm talking about? Okay. Aiden?
So if you play Minecraft, then if you follow a river down, then it usually ends up going over to the and then you can see like the water.
Yeah, exactly. Kind of like up here. Okay? This river is also carrying lots of sediments, with like maybe sand. Okay? Once it levels out and gets down to the bottom, it begins to drop off all that sand as it enters into the ocean. Okay? The sand begins to build up, and in places where the sand is too high for the river to go over it, it now has to branch out and go around. Okay? So this would be like dry land that you could walk on. All right? And then over time, it creates more and more and more of that. So you get a delta that looks more like this one. Okay? All right. That's delta. Next, we have sand dune. A sand dune is a mound or hill made of sand. And these hills often build up near bodies of water or at the foot of a mountain. Okay? Think about that. Makes sense. If wind is blowing and carrying sand, once it reaches a mountain, it can't go anywhere. It gets blocked. Okay? So the sand kind of gets dropped right there and then builds up into a hill. This is formed when wind-blown sand is collected in beach grasses or fixed objects. Okay? Just piles of sand kind of blowing up, building up. Sand dunes are formed by sand, silt, and clay, which are all very small particles of rock, carried off by the wind. Okay? Then eventually the hills build up to where it looks kind of like this. Okay? If you go out west of in western part of our country, out where the sand dunes, like where it's kind of more deserty, Arizona, New Mexico, Utah, Nevada, those kinds of places, they have like the great sand dune parks and stuff. You can actually go sandboarding as opposed to snowboarding. Have you done that before? Really? I never have, but I've heard good things. It's very cold. Really interesting. Interesting. Ian?
We went sledding on white sands national park.
Yeah.
Winter, so it was white
So it was.
plus snow.
Wow. Interesting. Cool experience. All right, and last one is a canyon. Again, we're going to write this down, and then I have a good picture / diagram I'm going to use to explain this to you. A canyon is a deep, narrow valley located between two rocky cliffs. This is one of the main differences between a valley and a canyon. The walls of a canyon are very steep and go almost straight up. A valley is more of a gradual slope. Okay? Steep sides and is formed as a river cuts a path deep into the Earth's surface. Almost everywhere you see a canyon, there is some river flowing at the bottom of it. The Grand Canyon, for example, almost positive, is formed by the Colorado River. Okay, thank you. I knew there was a river there, I just wasn't 100% sure it was Colorado, but I'm right. The river carries rock and other sediments away from the walls of the canyon, and over time, this forms a wider path and deeper sides. I'll explain that in just a minute. So canyons then are formed by flowing water. Okay? Once we're all finished writing that, then I have a good picture that explains how it forms. Yes. Okay, we talk about physical features in history. Okay. All right, so, for example, here's a canyon. This is what I'm talking about with the steep sides, okay? A valley, right, is more like a slope, kind of like this, correct? You can kind of like run down the hill if you want, and then down towards the stream. A canyon has steep sides like this. They go almost straight up. They kind of look more like jagged cliffs, kind of like in our poem, The Eagle, okay? Crag or whatever. So down here at the bottom, you see the river flowing through. This river, okay, is what's cutting into the earth, causing this deep canyon shape. Okay, so kind of look at this. Unless there is some other force on Earth, kind of acting on the canyon. Okay, so an earthquake, a landslide, a fault line, the tectonic plate starts shifting and moving around. Okay, that can help the canyon process along. But without any of those, the canyon started off as just a river flowing on flat ground. Okay, we just talked about how a river that's flowing through an area will pick up pieces of rocks, dirt, and things as it's flowing, correct, and carry them downstream. Well, where is it getting that rock and dirt from? From the riverbed. Okay, so as the river flows through an area and begins to pick up more and more rocks and dirt and chunks of stuff, it's cutting deeper and deeper and deeper into the earth, correct? Okay, so with time, the river erodes its bed, the riverbed, and cuts deep channels into the bedrock. Then, with more erosion and more time, it eventually carves out steep valley walls to form a canyon. Okay, so that river flowing more and more through the area as it takes more and more stuff away from the ground, digs a deeper and deeper hole, cutting into the earth, forming the canyon. Does that make sense? Go like this. That makes sense. All right. Riley, question?
I have a question and a comment. So, I went to the Glacial Valley.
Mm-hmm.
And when we did the village cover up, and
Oh, really?
now covering it up.
Whoa, that's kind of cool.
And could the canyon ever be without a river?
Could there ever be a canyon without a